Alright, so we left off in the final video with Bn, and I'd shown you how to calculate the integral of sine n pi x on 5 dx. So I'm just going to finish off the problem. That's what I'm going to try to do. Yes, finish off the problem. So what did we have here? We had Bn equals negative 2 over 5 negative 5 cos n pi x on 5. Sorry for reading it out to you. From 1 to 5. Okay, so we had that. Now it's as simple as just evaluating it. But if you don't know how to do it, that's fine. Well, think about, first of all, this 5 go bye-bye, so I'll rewrite it. And this negative will cancel out. So we will have Bn is equal to 2 over n pi. I'll also bring the n pi out the front. And that's just of cos n pi x on 5. From 1 to 5. Cool. Alright, what's cool? So then, what do? We evaluate this. Okay, that's real easy. So that's 2 over n pi. And that's cos n pi 5 on 5. So that's cos n pi. Now, cos n pi, this is something you just need to commit to memory, is equal to minus 1 raised to the n. And the reason why is because if you plug in a value of n for cos, so cos pi, right, that's minus 1. Cos 2 pi is 1. Cos 3 pi, negative 1. So this is alternating of values of positive and negative 1. So that's why it's minus 1 to the n. So think about it. So like minus 1 to the 1, that's minus 1. Minus 1 squared, that's 2, etc., etc. So these are equivalent statements. So when we plug in this value of 5 for x, we get minus 1 to the n. And that's over n pi still, but because we bring it out the front, it's irrelevant basically for now. Alright, what about cos n pi 1 on 5? Well, unfortunately, I mean, I could, if I wanted to, go on Google and type in what's the simplified version. I can't think of it. It's a sequence expression. The sequence expression for cos n pi on 5. And I could write down that sequence on Google, go to a Quora article, I think that's how you pronounce it, and find an equivalent simplification for cos n pi on 5. However, it's not a main one. For main ones, I use the simplified version, but otherwise I keep it as normal, if that makes sense. So basically, for the main ones, you would use something as like this to represent, but if not, you just leave it as it is. And it does make the answer longer, so make sure that you leave room on your page to write out the final expression for the Fourier series. But yeah, this is our expression right here. So Bn is equal to 2 over n pi, and you'll notice that n cannot equal 0, because if we did, then it would become undefined, because 2 over 0, bam, because this n's distributed to both terms here. Alright, so now we want to write down our Fourier series final answer. Well, we know we don't have a naught, so it's just equal to the summation from n equals 1 to infinity of Bn, because we don't have any cos terms, right? This is a Fourier sine series. So we'll just go back to the, I'm really sorry, we'll go back to the formula. So f of x was equal to a naught over 2 plus the summation, n equals 1 to infinity. And because we don't have an, we only include the Bn sine 2n pi x on t term. So we'll just go back to where we were. So it's going to be 2 over n pi minus 1 to the n minus cos n pi on 5 I'm I'm just trying to figure out how many brackets I need here. I think that's right now, yes. And then that's going to be multiplied by sine of 2n pi x on t. But we use the, that was just n pi x on 5. And that's our final answer right there. So this is Fourier series part 2, and I'll explain why it's just n pi x on 5 right now, because that seems a little bit confusing. But remember, I'll just give you a little tip, an easy way to think about it without explaining it too much. It's not hard. Remember here, what we had here when these two were the same in the previous video. This sine n pi x on 5 here will always be like this. Like, it'll always be what you multiply by your bn. So yeah. Thanks for watching, and I'll make more Fourier series videos just to, because that's how I got good at them. I did so many examples, and I got good at them like that. Hence how I got good at integration too. Yeah. I'll also start getting into my videos on simply supported beams and indeterminate continuous beams, and I might get into other forms of structural analysis like the stress transformation equations with more circle, and anything else that I feel like doing. And if you have any suggestions, let me know. Thank you for watching. See you later.